There she is. She is up. Again, I'll with everyone else as well, let you let you read the bios. But I will say one thing about Seema before I hand over to Dr. Bhangar. She has been educated both at Stanford and Berkeley, so I'm assuming has an annual dilemma as to supporting the bear or the tree. Or maybe you alternate between years. But anyway, Seema, thank you. I'm really happy that you are making the effort to do this online. And your work with the Green Building Council, I think, is really interesting. Applying your expertise in science to an organization like that, I think, is a great example of leveraging that background experience. So thank you for that. Thank you for your talk, and I'll hand it over to you.
Great. Thanks, Chris. It's Chris, right? I'm talking to the moderator?
Yes.
I can't see you.
That's correct. Thanks.
Yeah. So thanks for that introduction. And luckily, I now know what you're talking about, because when I just came to the United States, I was completely ignorant about football, but I have been inculcated. And yeah, thank you for inviting me. Thank you for the opportunity to be here virtually. I'm very sad. I'll echo Elizabeth and Robin, who was sad to not be here in person, especially now that I see that there's standing ovations to be had. But I'm exercising some source control and saving you all after a close COVID exposure in my family. So with that, let me go ahead and share my screen. There we go. And I will go to presentation mode, so you can see it better. Yikes. All right, sorry everyone, small problem here, but give me a second. I'm not able to make it full screen.
The bottom bar?
Bottom bar.
Yeah.
Oh, yeah.
Yeah, you're getting there. Right there. Got it.
Is that it? Slideshow. There we go.
Perfect.
All right. Thank you for the real-time help here. So my title today, Building Resilience for Health, it is intended to have a double meaning because we're here building resilience as an ecosystem of people, building resilience, buy-in from the people, and also resilience for buildings. We're making resilient buildings. And I am here to present a little bit more of a perspective from the building industry. So as Chris said, I'm at the U.S. Green Buildings Council. I've been there about a year. And before that, I had stints in commercial real estate in the tech industry. And then before that, I was in academia. And actually, my start in the air pollution world was in Kirk Smith's group on the cook stove work that just got discussed. And then I was in Bill Nazaroff's lab. So today we heard a lot from academics and from researchers and then from public health professionals. And so this is a more of a building industry perspective that you'll hear from me. And since moving from academia to industry, I've become more of a generalist and a translator from research to practice. So through this talk, I'm not going to be presenting my own work. I'm going to be citing many experts, and including all the ones who presented today. I think since it's the last talk of the day, I'm going to just take the liberty of being redundant a little bit by repeating what people have said to kind of wrap it up and bring it all together. So this is the outline. Since it is the last talk, I want you to know where you're at and how close you are to being able to get out of here and interact in person. So what is the problem? We heard from Piyush and Dan on the changing wildfire season, impacts of wildfire on air pollution in Canada, and then from Elizabeth and Michael on resulting health effects, generally and also locally in Canada. And so it's clear through everything we've heard that buildings now need to do more to protect against wildfires and other climate change-induced climate extreme events. So that adaptation piece, in addition to rapidly decarbonizing, which we've known is important for climate change mitigation. And it's worth saying that outdoor air pollution is not a new problem. I know we know that, but this picture from the left is one I took from a few miles from my parents' home in Bombay. And, growing up, this is the standard winter scene, smoky scene. And as Bill Nasroff covered, we've been designing and operating buildings to manage outdoor air pollution long before wildfires came on the radar. But wildfire risk has distinct aspects. So this picture on the right was taken by my spouse while backpacking in 2020, a period really influenced by the Creek fire in Northern California. And immediately visually, you see the different source profiles in the coloring of the air. And so not only are the composition and health effects different, exposure dynamics may be particularly inequitable, and the problem is getting worse and quickly. There was a really good talk earlier today about how other source emissions are going down, whereas the wildfire one is going up. And so we need to plan for this moving goalpost. And that's something that we really experience as a challenge in the configuring the LEED rating system, which USGBC administers. It's a green building standard. And we're asking projects and building owners and operators to think about and plan for the hazards they could be and will be faced with in the future. So, pointers, there were a lot of pointers there in the first two talks of the day of how to do that, that are useful for the building industry. So do we know how to address this problem? Scientists always answer maybe, so I'm going to make everyone happy by saying yes. We have a really solid understanding of pollutant dynamics in buildings to inform the design of interventions. This was sort of a thrust of Bill's talk. We also heard evidence on which interventions work from too many speakers for me to name individually. And to make it tangible, I've pictured here just a couple of anecdotal examples. So this one is courtesy a contractor called Balance Point, shared with me by a colleague from Lawrence Berkeley National Lab. And it's a building in the Tahoe area. It's a new build, so much easier to design for wildfire resilience, and where air quality was monitored indoors to be very good, even in extreme heat, smoke externally. And so these are just anecdotal examples. This is another one that's more of a retrofit. It's not wildfire conditions outside. It's from China, so another place similar to my own hometown with high chronic outdoor air pollution. And, this colleague, Liam Bates, just put a kind of home-rigged DOAS there. And he actually lives in Vancouver and rues that he cannot do the same type of retrofit in his rental apartment in Vancouver. And then Michael had an example as well, I think the Olympic Oval, also a new build. So we know how to do this. How do we do this? There are a lot of strategies, and they were very well covered. So I'll go through this section very quickly. Some of them are on the individual level. Patrick, how do you like that? I've summed your whole talk into one word there: behavior. So some building features are resilient, again, I think through the lens of the building. So some of the building features are confer resilience in the sense of offering individuals optionality and control. So behavior has an intersection there. And then, of course, individuals can engage, personal strategies, and training, messaging, data to inform action are all really critical here, as we've heard. So moving out from the individual scale, and just to tell you where it's going to go from individual to whole neighborhood. On the material level, we've always had the obvious strategy of burn-resistant materials on radar, and there's really exciting new research coming out from the Alfred P. Sloan Foundation Indoor Chemistry Program that just got concluded. Bill cited some of this on how sort of sorption dynamics, some of the chemical dynamics, so the interactions between wildfire smoke and materials in a space that can desorption dynamics that can lead to, chronic low dose exposure, secondhand, third hand after the wildfire has concluded. And then, as more and more homes are in regions that may burn, the toxicity of materials when they burn, we almost need to design in most places as if a material could burn and think about its toxicity. So, in the building and manufacturing parlance, I see the terminology, I started to use the terminology of multi-attribute management of materials. And then at the building scale, again, Bill and Eric especially covered this in great detail, how buildings can reduce the infiltration factor, what it's dependent on. So I'll skip over this, even though this is the real meat of strategies. And then there's the neighborhood scale. So, here again, it's been really well covered, but I just want to share kind of an image that really stayed with me. This was at a Building Resilience for Health workshop that I was at last year. And one of the speakers shared this, and it's of a house in Lahaina that, survived amid a big neighborhood that burned. And of course, there's great lessons there for what to do right, what worked for this house. But I also found it so sad in general looking at this. This is not our success story. We don't want individual homes that are great. We need communities and neighborhoods that are really good, because it's now this house is sitting essentially in a toxic waste site. And also, I think both Eric and Patrick emphasized this, is the inequities in adaptive capacity. And so that also really points at the importance of community neighborhood scale planning with measures such as the community air shelters we heard about. So that's a long list. It's very easy to generate a list like this. So I really appreciate that today we heard a lot of tips about how to strategize, how to go from having, a theoretical list of all these strategies to thinking about what works where and what should be activated. For instance, the filters being what we need when other kind of more source upstream interventions are not available or accessible. And so, it's really that I felt like today was a great set of guidance to go from list of strategies to sort of strategic implementation plan. So what are the barriers? There are many, many barriers have been shared today from the access, inclusion perspective. I'm really going to talk about barriers again from the building perspective, building industry perspective. So new buildings, there's no doubt, those are easier to address. Complexities in existing buildings make them more difficult to retrofit. But as we saw even in that little homegrown example, or as we heard with the air filters, it's not impossible. It's not impossible to take any existing buildings and create clean conditions indoors in extreme conditions outdoors. So why is this not already happening everywhere? Broadly speaking, I would say for it to happen bottom up, there needs to be a few things need to come together. Awareness of the value, acceptable cost, and then tools and training to facilitate execution. And of course, cost is a big part of that. And the problem is not that, using buildings as we call them, a pharmaceutical intervention, non-pharmaceutical intervention. Anyone who ever does an ROI calculation proves it out that this is worth doing, but there's that classic problem of split incentives, where who pays may not be who benefits, and that can jam things up. On the top-down side, there needs to be policy requiring action, but while there are so many players and actors who are in a position to influence indoor air quality in buildings, I think both Elizabeth and Bill mentioned this. There's no real central regulating body or accountable party. And, this gap came up in a big way. I think we all saw it in the COVID-19 pandemic, and there are many recent attempts to address it. And I'll talk about the silos piece in a little bit. And so, how does the green building movement affect change? Where do green buildings fit in? And I'll dwell on that a little bit, because that is my current industry that I've been in for a year. So I'm very excited to be learning about the use of this mechanism And thanks to Chris Pike for the slide. It's not my slide, it's a colleague's. So the theory of change here is that by codifying a set of voluntary standards and making performance transparent, we can incentivize action that we want to see happen, and where the market, so the bottom up alone, is insufficient to drive action, and where regulations, the top down, have yet to catch up. So that's the overall theory of change of green buildings. And in addition, a huge part of the idea of change here is that by codifying these standards, by driving practice, you create a community of very engaged, informed champions and pioneers that can then start to push on research, innovation, advocacy, education together. Apart from promoting specific strategies, several green building rating systems require or incentivize an integrated design process. So this starts to address that problem of silos. That's one of the barriers. It requires a whole project team, and by this I mean a buildings project team, so designers, owners, operators, possibly even local policy or community groups, to think of the entire building and all its systems together, emphasizing connections and improving communication among stakeholders throughout the life cycle of a project. So it kind of starts to break this gap between design and delivery, and then whatever happens after is sort of the problem of the operations team. So a few words about how resilience is addressed in USGBC's rating system. And LEED, which I'm going to talk about in this slide, is only one green building rating system. There are many, but LEED is the most widely used one in the world and the one with the longest history. So we have a 30-year history of LEED projects that generate a lot of data on what people have taken up, what works, and is also an indicator. Because of LEED's large footprint, it tends to be an indicator of what has resonance in the industry, and what people are looking at. And also, different green building organizations in general try to partner with each other. And I won't list all the different partnerships and network, but it's as much a movement as it is a set of individual organizations with products. And so a little bit about the main difference. So LEED v5, a new version of LEED, is about to be launched. It's entering public comment next month. So I hope you will all keep that in mind and engage in the public comment period and give feedback. And resilience, before v5, there were resilient measures that were included as what we call pilot credits, so where they're optional, whereas in the new version, it would probably be a prerequisite, and so required in all projects that are seeking LEED certification. Actually, skip over this. Current state, where are we now? So the best, as I mentioned before, we have pretty strong new build standards in some places, like California. I've heard colleagues who are more informed on this than me say, new builds in California, the problem is solved. That's an extreme view. Not everyone might agree. But the larger point is that, that level of stringency of standard is not adopted widely enough, and then it may not cover renovations and retrofits, of course. So that's a gap. Mara Baum is the person I turn to for Canada-specific building code, sustainability related, resilience related, but I wasn't able to reach her before this talk prep. And Michael shared, I think others shared, so I'll skip over this piece about the Canada piece, the Health Canada operational IAQ standard guidelines. Specific to wildfires, ASHRAE has in development new guideline 44. That's a graphic related to it is included on the bottom right there. And it's also worth noting ASHRAE 241, which is a brand new standard, historic for ASHRAE because it was created so quickly in response to the COVID-19 pandemic. And as Marwa Zatari, one of the key architects of that, likes to point out, it may be developed specifically for infectious diseases, but it has novel features relative to how ASHRAE has written standards in the past that make it very relevant for resilience to other things besides infectious disease, so including wildfires. So I'll skip over that and try and get to the end quickly. And I'll say, there are the point at a Johns Hopkins School of Public Health effort to write a Model State Indoor Air Quality Act, which is also aimed at creating more accountability, creating the central regulation and coordinating body in states where it's adopted. So with that, I'll just close with a set of recommendations, and these are not intended to be, a summary of what I think is most important, a summary of the day. They're not the most important things to do. It's more some things that I really care about and that in my current role I have a hand into. And so things that are front of mind and, passion points for me. So number one, activate the ecosystem. It's really we can't rely on regulations to come and solve everything or individual bottom up or top down alone. And, I think I think for the public health people, that's a really obvious point. Well, of course, and it's the role of, public health organizations and professionals to coordinate and do that activation and coordination. So I say this first point in a building industry group, and it has more resonance there. I think here it's just sort of preaching to the choir. The messaging, and this was a talk I saw from an NIH Climate and Health webinar series on the value of equipping primary healthcare providers to convey messages on climate change and resilience, and how that could get past some of the politicization otherwise of climate change messaging. So doctors, medical individual doctors have a lot of influence on people. Modeling and tracking community priorities is really important. So one of the issues, again, this gets at that point of strategic prioritization, because we have so many things, so many strategies we could use. And, there has to be a way to prioritize the most important ones. And so the advice here or the recommendation is, really go for the extremes in exposure, where there are extremes in vulnerability, and then go for that intentionally. Be a technology optimist. I heard this as a recommendation on talk, and I just really loved the ring to it. Assume better products in the future. So again, we're not just projecting on the problem side when we're planning for a future, the way this problem might look in the future, but also for the way the solutions might look in the future. There are a lot of infrastructure upgrades kind of being at least talked about as part of all the climate mitigation commitments globally at present. So Jason Hartke from IWBI made a really good talk recently about how we should not make this a missed opportunity. We're already going to be upgrading all these buildings to meet decarbonization goals. And at minimum, we shouldn't compromise health in that process. And at best, we should, tackle the resilience needs as well. Harmonizing interventions is important. I'll go quickly through the rest. Engaging the manufacturing community and that materials piece for the multi-attribute materials management is really big opportunity. Sensors, these are, pet passion for me. So I was excited to see a few talks on that, kind of reinforcing how they drive action by making invisible performance visible. So it's the, incentive of knowing and seeing what's going on. And then this ninth seems obvious, but so often missed in the buildings industry. Assume systems won't work as designed. So again, when you're planning for how things are going to work, do a very intentional analysis of what would happen if they didn't work. What are the risks of that? How to check, how to have better checks, culture of service, maintenance, and capacity. And then finally, this point about, systems thinking. And with that, I'll just pause for, I think maybe there's a few minutes for questions and hand to Chris.
Hey. It's too bad you can't see the room apparently, but a standing ovation for you. Amazing, right?
Yes, it's great, even to just think about.
You put that on your CV. So I'm looking for questions, and Dr. Brower is one of them. He probably needs a microphone because of the online nature of what we're doing here.
Thanks very much. I just wondered if you could maybe give an example of the strategic harmonization. I really like that framing, and actually want your graphics sort of cover that as well, and maybe some success stories there.
Yeah, and is that Mike speaking?
Yes, it was Mike.
Okay, yeah, great to meet you, Mike. I've heard so much about you. So yes, that's something that I've trying to think how to answer. I'll answer in two parts. First, I'll just share my own personal experience. My job before this was at the real estate company we work. And so that's where this really came alive for me because I realized being in real estate, the way it works is you get, if you're lucky, a fixed budget to solve problems that are very broadly defined. And so it's not helpful. It's not usually bottom up of saying, here are all the things, here's my wish list. It's usually much more top down. Here's an available resource. Go do something and then the problem is usually very widely scoped. And so that type of strategic prioritization is really important. And my main guidance or lesson learned on how to do that right is to think of really think in terms of staging, what's now, next, future, and think about the kind of performance you want in the future, and then think about how to get there with iterative improvements and a sort of testing, learning process. And I always thought of it as terms of a gateway drug. The thing you do first just needs to sort of create the channel where the place you want to be in 5 years you sort of drive toward it. And there's a really nice set of resources and guidance from, I want to say Tracy Enger at EPA, the tools for schools. Our Center for Green Schools at USGBC really emphasizes this and works with EPA and other partners to drive this in schools and sort of support that, strategic planning process around indoor air quality. So there's new publication coming out on that I can share after as well.
Cool. Thanks, Seema. Before we close, I want to touch on one thing briefly, because it's kind of been a theme that you mentioned this phrase technology optimism, and we've talked about technology. It's come up repeatedly. And I've had this long-standing, I think, ill-founded belief that more tech optimism necessarily comes at the cost of other types of primary prevention, sort of broad-scale public health interventions, et cetera. And I say ill-founded because I've never seen actual evidence, and we're scientists, or we should think scientifically. I've never seen any evidence that that's actually true, that it's a zero-sum game, that the more attention we put into tech, the less attention we put into, less technical, if you will, intervention. So I guess I'm asking you, but also the broad audience, and maybe it's too big a question or something for further discussion later, but if anyone knows of real solid evidence that this is a zero-sum game, that you have to choose between these, I would like to know.
So I can take a first step, provocative a speaker.
Sure.
So I don't have actual evidence, a study to cite here, but I will say that it's not an unfounded concern. I have the same one, and a good example, for instance, is the should buildings have passive survivability, or should they have really incredible automated dynamic controls? And these are both resilient strategies, but they sort of point in a different direction of what resilience looks and means like, looks and feels like. I tend to be anti-tech a little bit myself whenever it comes to a trade-off. So what I meant by that is, and to qualify, is that be an optimist in terms of how technology is going to advance and develop. So it's not necessarily about being optimistic about how technology will solve all our problems. And I think those are two, related but different things.
Well, I just want to remind everyone about, I'm going to let Connor answer, but I'm going to say this now and then I'm going to say it after Connor. The evaluations are really important. I think it stands to speak, I think, for all of us, that this is a very, very high quality year in and year out event, and it has a lot to do with the evaluations. We take them very, very seriously, I can guarantee that. So please fill them out as fully, completely, and robustly as possible. I'll say that in a shorter version in 1 second again. Connor.
And thanks, Seema, for that great wrap. So Connor Reynolds, I work with Metro Vancouver, and we do air quality monitoring and management, and we look at climate actions in our region. And so when your comment about technology, optimism spurred thinking, an important area for us, which is buildings make up a quarter of our region's greenhouse gas emissions, right? And they're not the new buildings. The new buildings are being done well, as you say. It's the existing buildings that are out there. And those are where largely the vulnerable populations are when it comes for, indoor air quality and wildfire smoke. So the technology optimist in me says high efficiency heat pumps, right? They are out there. They've been used for decades in many countries. They're becoming more common here. And so I think that, for me, I think this is the answer to, I think, the other elephant in the room, to use a phrase from Ryan earlier, that, is heat and the need for cooling. Because as soon as we're dealing with prolonged extreme heat, people are opening windows if they don't have access to cooling. And then you lose all of your indoor air quality gains. So I just wanted to put that out there, partially as a comment, but also to see if you have reflections on that kind of heat air quality nexus in the existing building space, given your current role.
Yeah, I appreciate that comment, Connor. And I don't have much to add except to just say that, yes, it's very helpful when we can decouple some of the different strategies we use in buildings, the way we set up buildings to manage different things. So whether it's, air pollution and thermal conditioning, moisture management, kind of our conventional systems that couple all these things, reduce our, optionality, which then reduces our, resilience to conditions that are unusual. So, yeah.
Awesome. Thank you, Seema. Again, evaluation is super important. I want to thank you.